van graad 12, so ek is terug. Kom ons gaan kyk nou na die volgende twee voorbeelde. We've got a curve or a function fx, x minus 2x squared, with a gradient n equals 9, the gradient of the tangent that touches at a specific point. That's the gradient of that tangent at that curve. So die vraag wat hier gevra word is bepaal die raakpunt, determine the point where the function and the tangent touches, and then determine the equation of that tangent. So kom ons gaan eers en ons gaan sien wat is vir ons gegee. The curve fx or the function fx is given and the gradient of the tangent. So as ons gaan kyk na die gradiënt van die raaklyn, dan weet ons die gradiënt van die raaklyn is die afgeleide van die funksie by 'n spesifieke punt. So let's quickly derive, and that's going to give us the gradient. So if we derive, we've got a 1 to the front, okay, and x to the power of 0 gives us 1, minus 2 times 2 gives us 4x, and that is the derivative, and that gives us the gradient of the tangent at a specific point. So that equals 9. If you know your learning work, you will be able to figure that out. So now we can determine x. Kom ons gaan bepaal vir x. Ons kan vir x hierdie kant toe vat en ons kan vir 9 hierdie kant toe vat. 1 minus 9 is minus 8. So the x value of the point of contact is going to be minus 2. Om die y-waarde te kry, kan ek net die x-waarde binne in die oorspronklike funksie gaan insit. You can't put in the x value into the derivative because the derivative is the gradient. It's not the equation of the tangent. So ek gaan f minus 2 binne my oorspronklike funksie substitusie doen. And I'm going to determine the y value that forms that coordinate. So ek het minus 2 minus, en dis 4 maal 2, wat 8 is, so dis gelyk aan minus 10. So the coordinate of the point of contact is going to be minus 2, minus 10. Now the next question is, determine the equation of the tangent. Bepaal die vergelyking van die raaklyn. So kom ons skryf ons vergelyking neer. Standaard vergelyking is gelyk aan n x minus x1. We've got the gradient and we've got the coordinate. So dis baie maklik. Wees nou net versigtig vir hierdie minusse. Daai minus is deel van jou vergelyking. So when I substitute, I'm going to substitute minus 10 like that. Gradient equals 9. And I'm going to substitute my x value again as minus 2. Two minuses next to each other. That gives us y plus 10 equals 9x. And that's a plus 2, so it's going to be plus 18. So to get the equation, take the 10 to the other side of the equals 2. So the equation of the tangent is going to be 9x plus 8. Vergelyking van my raaklyn. Goed, baie maklik. Ons gaan net vinnig weer deur wat het ons gedoen. Juffrou het vir jou 'n funksie gegee en ek het vir jou die gradiënt van die raaklyn by 'n spesifieke punt aan daardie funksie gegee. So to get value of the contact point, I had to get the derivative and equals it to the gradient. Van die afgeleide van die funksie gee ons vir my die gradiënt by 'n sekere punt. So if I then get the x value, that's the x value of my contact point. To get the y value, I substitute it into the original formula. Die oorspronklike formule om sy eie maatjie te kry. Got the contact point, substituted the coordinate as well as the gradient, and I got the equation of my tangent at x equals minus 2. Kom ons kyk gou-gou na die volgende vraag. Die volgende vraag gaan oor die funksie fx is gelyk aan x tot die derde mag plus 2x² minus 4x, the function, the curve that we are working on. And they say that this curve got 2 tangents, and these 2 tangents are both parallel to this straight line. Juffrou herhaal. Die funksie sê hulle, daardie funksie het 2 raaklyne wat ewewydig is aan hierdie reguit lyn, en die vraag is, bepaal albei die vergelykings van die raaklyne. So let's quickly go to this guy. And we get it in the standard form. Want waarin stel ons belang? Ons stel belang in die gradiënt van hierdie ouetjie. Want as die 2 raaklyne aan hierdie kurwe ewewydig is aan daai ouetjie, beteken dit they've got the same gradients. So let's quickly write that in standard form. Take the minus 5x to the other side and the 7 to the other side. So our gradient equals 5. So that means the gradient of these 2 tangents will also be 5 because they are parallel, both are parallel to this straight line. So that's all that I need from this guy is the gradient. Now, to get the gradient, I'm going to get the derivative of fx. Let's get the derivative of fx. That's going to be 3 to the front, deduct 1, 2 to the front, deduct 1, and 1 to the front, deduct 1. So that must then, according to our knowledge, equal the value of the gradient, and that's going to be 5. So by determining the 2x values over there, I'm going to get the x values of the 2 points of contact. So ek gaan nou hierdie x oplos, en dit sal my 2x waardes van kontak wees. Met ander woorde, die 2 koördinate waar die raaklyn gaan raak. So let's get this in standard form. We're going to factorize. Ons kyk gou, ek het 'n 3x en 'n x, en dan het ek, kom ons gaan kyk, ek het 'n plus 9, ja, plus 9 dalk, en 'n min 1 of 'n 3 en 'n 3, kom ons probeer 'n 3 en 'n 3, let's put in 'n plus, let's just quickly check whether it can factorize to the 3x squared. It's not a 6. I've written it down incorrectly. Sorry guys. 3x squared minus 4x. Just quickly see. That x must be a 6. Why? 3x squared plus 3x minus 4 equals 5. 3x squared plus 6x minus. Okay, I did. Let's just quickly see. 3x cubed 3x. Oh, this must be a 3. Sorry, I've written it down incorrectly. That must be a 3x squared, so that's going to be a 6. Sorry, grade 12s. So that's going to, otherwise it's not factorizable. So it's going to be 6x minus 9. So I can take out the 3 as a common factor. And then it's, let me just do that. I've written it down incorrectly. So I take out the 3 as a common factor. It's x squared plus 2x minus 3. And then we can factorize and get the 2x values. It's x plus 3, x minus 1. And then we get the 2x values. So x equals minus 3 or plus 1. Then we can substitute this x values into the original formula. The original formula was y equals x cubed plus 3x squared, x cubed plus 3x squared minus 4x. Okay, so I'm going to substitute the minus 3 into the original equation. Plus 3 times minus 3 squared minus 4 times minus 3 en dit gee vir my minus 27. 3 maal 9 is plus 27 plus 12. So dis die y-maatjie van die min 3. So we're going to do exactly the same. Now for the plus 1, it's 1 cube, plus 3 times 1 square, minus 4 times 1, and that's going to give us 1, plus 3 gives us 4, minus 4 gives us 0. So the 2 points of contact is going to be minus 3, 12, or it's going to be 1, 0. That's the 2 points of contact. Okay, now we must determine the 2 equations of the tangents. So the 2 equations of the tangents that's parallel to that straight line. So ons het nou die 2 kontakpunte, ons het die gradiënte, so ons kan nou ons standaardvergelyking gebruik en ons kan albei in standaardvergelyking. Wat ons in hierdie geval gebruik is hierdie ouetjie wat ons ken al van graad 10 af. So let's substitute the first one. We've got y minus 12, our gradient 5 for both, x minus, and the x value equals minus 3. Okay, so let's simplify. 5 times x, 5 times plus 3, and then we take the 12 to the other side of the equals 2, dan word hy plus, so ek het 5x plus 27. Dis een van my raaklyne se vergelyking. Kom ons kyk na die ander raaklyn se vergelyking, weer in daai standaard vergelyking. My y-waarde is 0, my gradiënt is nog steeds 5, en my x-waarde is 1. En nou kan ek gaan uitvermenigvuldig, very easy, 5x minus 5. So I've got the equations of both the tangents, 5x plus 27 and 5x minus 5. Graad 12, dit is nie moeilik nie. As 'n ou dit verstaan, then it's very easy to be able to answer these questions. Go and practice. Sien vir julle môre.